8-digit 7-segment displays are great components to display data coming from microcontroller-based devices. And as long as they work well with numbers, it's a bit tricky to show letters, not even mentioning special characters or bitmaps. It seems logical though, they've got only 7 segments. So if your device needs to display something else than number, I suggest going for different type of component. And that component would be an OLED screen. This type of display can give you 128 by 64 or even 128 by 128 pixels of resolution to show any kind of data, like numbers, text, or status icons. And today, I'm gonna show you how to use them with ESP8266. Hey, it's Thomas and this is day 44 of 100 Days of Code in IoT Challenge. Let's get started. So first, let me start from showing you all the parts and components I'm gonna use today, and I'm gonna start with the screen. So this one is I2C OLED screen model 1306. The resolution of that screen is 128 by 32, so it's one of the smallest, but it's gonna be more than enough for showing you the basics. Then I've got ESP8266 microcontroller with micro USB to USB cable that is gonna be connected to my computer, bunch of wires to connect everything together, and these 3 buttons to play around with the input for tomorrow's video. Okay, so these are all the parts, and now I'm gonna connect the screen to ESP8266. Okay, connected. So let me just quickly go through it. Starting from the power supply, that device needs 3.3 volts. So what I've done is to connect 3v3 on the microcontroller with the VCC pin on the OLED screen. Right, and that is the red wire. That is the red wire in here. Okay, and then the ground from the device, the black wire going to the minus rail that I'm using as the common ground. And as you can see, the blue wire in here is connected to the ground on the microcontroller side and to the minus rail here, right? So that is our ground. Anything that needs to be connected to the ground, it's gonna be connected to that rail. Right, and now the most important, which are those 2 pins on the OLED screen, SCL and SDA. Right, and it is important to connect SCL with D1 on the microcontroller and SDA with D2 on the microcontroller. This is very important. Don't connect it to any other pins. It has to be D1 and D2. D1 for the SCL again, and D2 with the SDA. Okay, cool. So now that I have the screen connected, we can move to the code. On my computer, I'm going to go to Visual Studio Code that I have already opened. And from here, I'm gonna click on the PlatformIO icon and then open from here. In the PIO home screen, I'm going to click on the new project. For the project name, I'm going to call it OLED screen. And then board, it's going to be Node MCU 1.0 and framework Arduino. And then I'm going to click on finish. And that should create a new project for me. There we go. Okay, that opened a platformio.ini file automatically. And inside this file, there is going to be one option that I'm going to add, and that is monitor speed. That's gonna be set to this number. Okay, and I'm gonna copy that number, open src main.cpp, and then in the setup function, I'm going to type serial begin and pass that value to serial begin. And after that, I'm just gonna call delay with 2 seconds. This is for the serial communication to synchronize between IDE and the microcontroller. Okay, now that we have initial setup done, let's think about the simplest use case we can do with this OLED screen, right? And the one I'm thinking about would be to display some text, right? That seems reasonable as the simplest use case, and that's the one I'm going to start from, right? But before I write any code, there are a few libraries, three libraries I'm gonna have to install with PlatformIO to start. Okay, so to install them, I'm going to go to PlatformIO, so clicking on the icon in here, then open, right? And from the PlatformIO welcome screen, right, I'm going to go to libraries, and in a search libraries text box, I'm gonna type GFX. GFX, and the first result that comes up, which is Adafruit GFX library, is the one that we're going to install. So I've just clicked on it, and then add to project, select a project, and OLED screen project, which is the one I've got opened here, right? So I pick that one, and now I'm going to click on the add button, and that is gonna add it to my project. Nice, okay, so that's done. Right, okay, and now the second one. The second library is for my particular model of the screen. The model of the screen is SSD1306. So that's what I've typed into the search box, and again, the first result that comes up, Adafruit SSD1306, is the one that I'm going to install, right? So I'm just gonna follow the same instructions for installing a new library. Okay, add, done. Okay, second one down. And now the third one, that is a bus.io, Adafruit bus.io. So again, I'm gonna click on it, then add to project, select project, project's OLED screen, and add button in here. Nice, okay. Right, so all the required libraries installed. So now I need to include them. So that's going to be Adafruit SSD1306. That's the one that we're going to create. From this header, we're going to use one of the classes in there. The name of the class is actually the same as this one, but this also requires me to include wire.h and SPI. SPI.h. Okay. Nice. Okay, done. Right, and now the new instance of Adafruit SSD1306. So I'm gonna just statically create an object. Let's call it OLED. And that takes a few arguments in the constructor. The first argument is the width of the screen. My screen is 128 by 32, right? So the first one is the width. Let me just show you which overload is this. Not this one, not this one, this one that I'm using. You see? So we have width as 128, 32 is height. The third one is 2 wire. And there is actually it's already, hang on, that's not, yeah. You can already see that uses wire. It seems like it's a default parameter, so maybe they changed something since I used it last time, but I'm still gonna pass these two arguments. They seem to be default, but I'm still gonna pass them, right? So wire is a pointer to wire, which is required by this OLED, and -1, this is for the reset pin, and that's just the default value. So maybe I could even skip them, but you know, just to be safe, let's keep them. I can try later on to remove them and see if it's still working. Okay, cool. Okay, so we've got the instance created, but we have to initialize it. We have to initialize the screen. And to initialize the screen, there is a begin method, right? That begin method takes 2 arguments. First argument, which is a switch VCC. And for that, I'm going to pass actually the one with the switch VCC. Hang on. It is, yeah, this one, switch CAP VCC. And the second one is, it depends on the type of the screen you have. And because I have 128 by 32, I'm gonna go for the 3C as a hexadecimal, okay? Okay, Right, so that allocates all the required memory, but if that allocation fails, it returns false. And that's something we can actually detect and print an error message to the serial monitor that something went wrong, right? So we can do something like that. Allocation failed. Right, so if that fails, that's gonna be it. We're just gonna get a message in a serial monitor, allocation failed. But yeah, we probably not gonna get it. Nice. Okay, so that's just, you know, that just allocates everything that is needed to start the screen. And now what I usually do is to run a clear display and then just display. That is to make sure the screen is empty before we start writing to it. Okay, so yeah, so that is covered. And now there's gonna be another clear display. Yeah, and I encourage everyone to experiment with that because it might not be required. We may just need to clear display once, but that's just, you know, that's just based on the snippet that I created in the past, and that worked for me only in this way, right? But it might have changed by that time. Anyway, so clear display, and now before we can write to it, we have to call a few methods, right? Do a few instructions. The first instruction is gonna be to set the text color, okay? So set text color, and we can only pick one of two, right? We don't have much of a choice, and that is either black or white. And because the default background color is black, I'm gonna use white, okay? So that's gonna be SSD1306 and white. That's the constant that I'm supposed to pass. Now, set cursor. This is also important. So this takes X and Y coordinates from where we would like to start typing, okay? If I pass 0, 0, that's gonna be, I think, bottom right. And from that point at the screen is going to start writing the text that I would like to write. Cool. Okay, so we've got cursor, we've got text color, and now what is missing is the text size. Otherwise we will get a very small text, and that's not something I would like to get. Yeah, on the text size, it is important that if you have a screen that has a height of 32, the maximum size you can get is 4, right? According to what they say in here. You see the 3 is 18 by 24. So I guess the next one is going to be, that's going to be 24 by 32, right? So if you do 5, you probably won't be able to see the text. However, I'm not going to go for 4. Let's do 3, right? So we're going to do 3. And finally, I can call a print method that prints something. Let's do hello, okay? That prints something on the screen. But that doesn't display anything yet. At this point, we won't have anything displayed. To display something, you still need to call another method that has been called already before, and that is display, right? So calling display is actually going to display hello. Cool. But for our example to not be too simple, I'm thinking about adding a little bit extra, and that extra would be a few more words that we display with the 1 second break, 1 second pause, right? So think about the program where once it's deployed, it displays hello on the screen, that there is a 1 second pause, then we have from 1 second pause, ESP8266, 1 second pause, and that's just gonna start again, start over, right? So we will again have hello from ESP8266 and so on, right? So let's do that and deploy this sort of functionality. And in order to do this, first of all, I'm gonna have to move this bit of code to the loop function, right? We would like to repeat the sequence again and again, right? So hello from ESP8266. So that is one thing. Another thing, I don't want to repeat myself like that, right? Because to display another piece of information, I will have to copy it and paste and then change the message. But that's not something I I usually do when I code. I don't like to repeat myself. So to avoid this kind of situation, I'm going to create a function. I'm gonna call it display text. That's gonna take const char pointer text, and it is going to run this exact set of instructions. However, instead of passing hello, that is going to pass text, right? So that should simplify the code, because now in the loop function, I can just run display text hello, okay? So we've got hello, and as I said, 1 second pause. Then we have from, okay? Again, 1 second pause, ESP8266, and maybe let's add another one, just a simple smile in here, and another delay, right? Another delay. So that's gonna be the delay before it starts over, right? So hello from ESP8266. Okay, so that should display some information on the screen, yes. Okay, yeah. Right, so yeah, now make sure your ESP8266 is connected to the computer through USB cable. It is in my case, and I'm going to click on the deploy button in here, and let's see what we get. Okay, deployed, and as you can see, we've got text appearing on the screen, right? Hello from ESP8266 and a smile. Okay, cool, so we can display text, right? And now let me show you how to do the bitmaps. And to display a bitmap, yeah, first step, I'm going to clean up here a little bit, because yeah, we're not gonna be displaying text anymore. The display text function can stay in the code, but I'm going to move it somewhere else. Right, we're not really gonna use a loop function, because that's just gonna be, you know, displaying the bitmap, that's it. So the code is gonna go here. And also there is a different method that you need to use to display it, and it's called draw bitmap, right? So it's actually self-explanatory. The arguments that you need to pass is x and y coordinates, the bitmap itself, which is supposed to be an array of bytes, okay? So you see you unsigned int 8, type, okay, and then width and height, and the color of that bitmap, right? So yeah, there are two ways for creating this bitmap. One is to create it pixel by pixel from scratch here in the code, and that's not something I'm gonna do, because that would take too much time, okay? Instead, I'm gonna use a very, very nice tool. So if you go to Google and you look for OLED bitmap converter, the second result, image to CPP, that is very useful tool, because what you can essentially do is to upload any file, and that file is gonna be converted to black and white bitmap, okay? Let me show you this on an example. So I'm thinking, because this is ESP8266 and Internet of Things challenge, I'm going to look for the Wi-Fi symbol, and we're going to display it on the screen, okay? So I'm going to images, and let's pick something from here. Maybe not this kind of symbol, because it's not stretched enough. Something like that, but you know, without this little guy in here. Oh, maybe this one, okay? This one. Yeah, let's go for this one. So I'm gonna open it in a new tab, save it on my computer. Nice, okay, and upload it from my computer to this tool, okay? So yeah, just uploading in here, and instantly you should see it here, right? But that's the original size. That's not something we can actually display on our screen, because our screen is too small. So in order to change that, I'm gonna have to change the size right here, the width and height. So that's gonna be 128 by 32 now. There's nothing in the preview at the moment, and this is because we have the scaling set to original size. That needs to change. That needs to be scaled to fit, keeping proportions. Nice, okay, so we can see it here. However, as the default background color of the OLED screen is black, I think it's gonna look better if we invert the colors, okay? So I'm gonna go for the invert image colors in here. That changed it, right? So we have a black background and a white icon now. A second thing I would like to do, and I think it's gonna be a good idea is to decrease this 128 maybe, because you see, we cannot really stretch it more. I mean, we could use this one possibly, but that doesn't look nice, right? Isn't it? So a scale to fit is fine, but let's decrease it to 48 so we also save some memory. And finally, I don't like this white here. So the white stripe or something, right? So I'm gonna change the background color to black because yeah, that's the default background color on our screen. Nice, okay, so something like that. And now in the output section, we're not really gonna go for Arduino code, but Arduino code single bitmap, which is slightly better because it's less code essentially. We just get the bitmap variable array, which is what we need to copy paste, okay? So yeah, so I think I've got everything set, and what I can do now is to generate code. Nice, okay. So that gives us an array. There's a small error in here. You see NaN, not a number. I'm gonna have to rename that. But yeah, let me copy paste it first. And in here, yeah, let me change that to bitmap. Right. So now that we have an array, a bitmap, you see the format here. Right, it's a hexadecimal, it's just bytes of that bitmap. And in the draw bitmap, I can pass X and Y. And here, you know what, maybe I won't do 0, 0. I would rather like that symbol to be displayed at the center of the screen. So let me think about it. I think 48. Around 48 it should be, 64 or 48, I think it's 48 because 64 would start right in the, drawing it right in the middle, right in the center, so it'd be a little too much to the right? We want this to be exactly at the center, so I think 48 is reasonable value. Not sure if it's gonna be, you know, the center, really center, it might be a little bit to the left or right, but we'll see. Y we can keep 0. Bitmap, then width and height, so that's gonna be 48 and 32, right? The same ones I have defined in the tool, in the image to CPP tool. And the final value here is supposed to be the color, okay? So the color is gonna be SSD1306 white, right? Okay, so draw bitmap and display. Okay, to actually display it, we still need to call a display method. Nice, okay, and that comment is redundant now. Nice, okay, so yeah, we've got this done, and I think, yeah, let's go ahead, deploy it, and let's find out how this is going to be displayed. Deployed, and as you can see, we've got an icon displayed in here, right? And now the final exercise today, let's have a little bit of fun, okay? So I'm gonna keep all of this code as it is, except for the bitmap, right? So instead of displaying an icon, I'm thinking about displaying an actual image. And for that image, I was thinking, let's pick a meme, okay? Let's pick some memes, so maybe Doge would be a good idea. What happens if I try to convert this famous Doge image into an actual bitmap, okay? Let's see what's gonna happen. I've just downloaded it on my computer, and yeah, let me refresh that on this image to CPP tool. Yeah, let's see. I'm actually curious how the result is gonna look like on the screen, because it's very limited, isn't it? But that image is an actual image, so yeah, let's see. So yeah, that is an actual bitmap in here. What happens if I scale it to 128 by 32? Okay, yeah, I guess, like, you know, that still resembles the actual image, isn't it? I mean, if you were told it's a Doge, it looks like a Doge. Yeah, I'm gonna give it a go. So let's do Arduino code single bitmap, generate code. I'm gonna copy paste it. But obviously let's change this not a number to bitmap. And also, because the size changed, right? We're gonna have to change it in here as well. So we're gonna start from 0, 0 now. And the size of an image is 128 by 32 now, okay? So that is important, otherwise we won't see the Doge on the screen. Cool, okay, yeah, I think that's it. That's it, yeah. I'm going to deploy it, and let's see how this is gonna look like on the screen. Okay, and here we are, our Doge here. A little Doge on the OLED screen, right? We can definitely tell this is a Doge, can we? Yeah, I guess we need to have a slightly bigger screen. I guess like 128 by 64, or ideally 128 by 128. But yeah, that's how you display bitmaps on this kind of screens. And this is it for today. To sum it up, we managed to display text, an icon, and an image, a meme image at the end, right? Thanks for watching. If you like my content, don't forget to subscribe. The button is below. And yeah, see you tomorrow.